Welcome back. At first, happy Teacher's Day because today is Teacher's Day. And at first, respect and pranam to all my teachers and my Gurudev. Now, I will tell you two quotes of Swami Vivekananda about teachers. First quote: experience is the only teachers we have. We may talk and reason all our lives, but we shall not understand a word of truth until we experience it. I hope my all viewers have understood the meaning of teachers. Second, the Guru is means realization. There is no knowledge without a teacher. So, since today is Teacher's Day, so today's video I have dedicated to all my teachers and my Gurudev also. Okay. Today's lecture about metric topology. Metric topology is topology which is induced by metric. So, before starting the metric topology, just quickly recall what is the metric on a set. Then I will see what is the metric topology. This is today's goal of this lecture. So, just quickly recall the metric on a set. Metric on a set is a function which is defined d from x cross x to r having the following properties. First, d of xy greater than equal to 0 for all xy in x and d of xy equal to 0 if x equal to y. Second, d of xy equal to d of yx, and this is true for all xy belongs to x, and this is the symmetric property. Say third is triangle inequality. D of xy less than equal to d of xz plus d of zy, and this is true for all xyz belongs to x. This is the triangle inequality. And then the pair x comma d, where d is the distance, is called metric space, and the map D is called metric on the space is on x. This is the metric space. Now I will see how look like the metric topology. Metric topology. This is if D is a metric on a set x, then collection of all epsilon balls which is denoted as BDX epsilon for each x belongs to capital X and epsilon greater than 0. All this collection of epsilon ball is a basis for a topology on X. This is called metric topology which is induced by D. That means B equal to those ball BDX epsilon where for each x in X and epsilon greater than 0. And BDX epsilon means set of those y in X such that d of xy less than epsilon. That means if this is x, and if this the point x, then this is the open ball, and here we can take any epsilon, so all would be the basis. Similarly for other, I hope my all viewers have understood how look like, and this is the basis for metric topology. That means metric topology actually induced by metric space, which is the collection of all open balls, and this is satisfy all condition of basis, the definition of basis. Okay, let's check oneself why this is basis of metric topology. Just easy, try to answer. If you have any queries, then comments in comments box. And I hope my all viewers have understood what is the metric topology. If you don't see my previous video of metric space, at first see this video. There are many couple of example on metric space, which are metric, which are not metric. If you don't see my previous video, at first I will highly recommend you see the previous video of metric space. Then you will understand this video, metric topology, in better way. Because if you don't understand the metric space and example, different type of example, then you never understand the metric topology. Okay, so see my previous video of metric space. I have given some link in description box also. Since topology generated by basis, so metric topology is generated by this type of open ball, and this is the basis of this topology on the set X. For a set X, define a metric d of xy equal to 1 when x not equal to y and 0 when x equal to y. We all of us know this metric is called discrete metric. So, on this set X, we can define a topology induced by this metric, and this is called discrete topology. I hope my all viewers have understood the metric topology. Okay. R with usual metric is denoted as, here open ball is look like x minus epsilon comma x plus epsilon, and this is actually the open interval, and this metric is actually induced a topology, and this is called standard topology. That means standard topology is induced by usual metric. The most common example of a metric space on Rn with Euclidean metric, and this is xy belongs to Rn such that x equal to, since xy belongs to Rn, that means x equal to x1 up to xn and y equal to y1 up to yn. Then d of xy equal to summation I equal to 1 to n xi minus yi whole square to the power half. This is known as Euclidean matrix. So in Rn we can define Euclidean topology which is induced by Euclidean metric. If X is a topological space, then we say that X is metrizable If there exists a metric D on the set X whose generated class of open set is given topology on X. That means if X is metrizable if there exists a basis D on the set X that induces a topology. I hope my all viewers have understood when a topological space is metrizable. That means there exists a metric D that induces a topology. Today I will stop here. I hope my all viewers have understood what is the metric topology and when a topological space is said to be metrizable. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much and happy Teachers Day again.